So far, we've only been handling or catching exceptions, but sometimes we want to throw an exception. Let me show you an example. So in this package, the exceptions package, I'm going to add a new class called account. Here we need a method for depositing money into this account. So public void deposit. We give it a parameter of type float called value. Now this value has to be a positive value. It doesn't make sense to pass 0 or -1 here. So we can validate this argument and throw an exception. If value is less than or equal to 0, we throw, so we type the throw keyword, then we create an exception object. In this case, new illegal argument exception. We're telling the caller of this method that they have passed an illegal argument. Now, back to our demo class. Let's create an account object and then call account.deposit with -1. When we run this program, our program crashes because we have an illegal argument exception. This is a runtime or unchecked exception, which indicates a programming error. So we shouldn't handle this with a try-catch block. We should come back and fix the source of the problem. So we pass a +1. Now the exception is gone. So this is how we can throw an exception in Java. Now, this technique that we have used here, validating this argument and throwing an exception, is called defensive programming. So if a negative value here can cause a serious problem down the road, we throw an exception and prevent the rest of our code from getting executed. This is why this technique is called defensive programming, because we're coding in a defensive manner. So our code is immediately telling that it cannot work with a negative value. This is better than letting this negative value get some serious problem down the road. For example, you may store it in a database, and sometime in the future, you read it, and then something really weird happens in your application. So this is the benefit of defensive programming. Having said that, as I always say, too much of a good thing can be a bad thing. Adding this validation logic and throwing exception adds a bit of noise to our code. It makes our code a bit longer and more verbose. This is a very simple example, but what if we had a method with 3 parameters? With this approach, the first 6 lines of this method would just be data validation logic. So I would say it's better to use defensive programming if you're building a library or a framework for others to use. If you're building an application, you should have a level of trust in your code. Your methods should trust each other. So don't pollute every single method with data validation logic. Perform this kind of validation only when you receive input from the user or external systems. So at the boundary of your application, but not within the application itself. Now here we're throwing a runtime or an unchecked exception, but what if you want to throw a checked exception? Let me show you. So I'm going to replace this with IO exception. Now we have a compilation error, unhandled exception, IO exception. So the Java compiler is saying we haven't handled this exception. Now, should we wrap this inside the try-catch block? No, it doesn't make sense to throw this exception and handle it right here. We want to throw this exception in this method and have the caller of this method handle that exception, just like how we use the FileReader class. So the FileReader class throws an exception that we have to explicitly handle. So to get rid of this compilation error, over here in the declaration of this method, we should specify that this method may throw an IO exception. So we type throws. Note that this is throws, but here we're using the throw keyword. So throws IO exception. We're basically telling the caller of this method that this method may throw an IO exception. So this is part of the API of this method. API is short for Application Programming Interface. So anyone who wants to use our account class should know that the deposit method takes a float and may throw an exception. These details represent the interface or the API of this method, okay? Now, back to our demo class. The Java compiler is saying that we haven't handled this exception. So this is where we wrap our code inside the try-catch block. There you go.